Okay, in this section, we're going to focus on that third scenario of asymptotes, the ones where the numerator was greater than the denominator from last time's lesson. But before we get into that, let's just do a quick review of what we did last time. So we're given the following function, h of x equals 2x minus 4, and then x squared over x squared minus 4. So remember, when we're trying to analyze these functions, first thing we want to do is factor. So I'm going to go ahead and factor that. That's going to be 2 and then x subtract 2 over x plus 2 and x minus 2. Okay, if we have the same factor in the numerator and the denominator, then we know we have a whole, so we do have the same factor. So that means we have a whole at x equals 2. Okay, so to actually find the point, remember, you're going to take what you get after you reduce the factor out. So that's going to turn out to be 2 over x plus 2. So this is the reduced form. Take the 2, so take our 2, and we're going to substitute it right here for x. So that's going to leave us with 2 over 4. So that's going to be a half. So our whole is at 2 a half. And then to find our vertical asymptotes, we're going to look at, I'm going to erase this piece right here. We're going to look at our denominator, and notice right here is the only thing we have left. We've already taken care of the whole at 2, so we know that x cannot equal negative 2, so that's our vertical asymptote. X equals negative 2. That's the one we can't use because we know that's our vertical asymptote, because when we put negative 2 in, it makes us divide by 0. And our horizontal asymptote, remember, we're going to go back to the original. We're going to look at the degrees right here. This degree is a 1. This degree is a 2. Numerator is less than the denominator. When that's the case, then your horizontal asymptote is y equals 0. Okay, so we don't even have to have a picture. We should be able to algebraically come up with this information. So here we go. As a quick review, we're going to want to find all the vertical and horizontal asymptotes without even looking in our calculator. We got to be able to do it algebraically. So vertical asymptotes, you're going to want to make sure everything's factored first. So this is going to go 2x squared over x plus 3 and x minus 3. So my vertical asymptote is going to be at x equals positive and negative 3. My horizontal asymptote, when I look at this, I notice that the degrees right here are the same, 2 and 2. So that means the horizontal asymptote is the ratio of the leading coefficients. Well, that ratio is 2 over 1. So this one is y equals 2. All right, on the next one, we've got y equals x to the third minus 3x minus 4 divided by 2 subtract x. So our vertical asymptote is going to be at x equals 2, because we can't use 2. 2 subtract 2 is 0. We can't divide by 0. Horizontal asymptote, if I look at this one, I can see the numerator is a 3 and the denominator is a 1 right there. So there's a 1 right there for the denominator. And that means the numerator is bigger than the denominator. So that actually means there is no horizontal asymptote. That's what we're going to do today. Today's lesson is going to deal with that scenario. Okay, question number 3. When I look at this one to find my vertical asymptotes, is there any number that you can put in for x that will make you divide by 0? I don't think so, because you're taking x and you're squaring it. So that's always going to turn out to be a positive number, and you're adding a 2 to it every time. So there are no vertical asymptotes on this one. And then the horizontal asymptote is y equals 0. The degree of the numerator is less than the degree of the denominator. Okay, question number 4. If you go ahead and factor that, you're going to end up with x squared over 3 times x plus 1 and x minus 1. So your vertical asymptotes are at x equals positive and negative 1. The horizontal asymptote is at 1/3. Y equals 1/3. Okay, how did I get that? Well, looking right here, this degree is a 2, and this one, if you were to multiply that out with the distributive property, you would have ended up with, instead of factoring, I would end up on the denominator with 3x squared minus 1. So that's a degree 2. So remember, the horizontal asymptote is the ratio of the leading coefficients, so that would be 1 over 3. So that would be 1/3. Okay, number 5, we're going to factor that. Factor the denominator. So 2x, x, 3 plus and minus. So now this right here is a whole, x minus 1. So if it's a whole, it can't be a vertical asymptote. So we only have one vertical asymptote, and that's at x equals a negative 3 over 2. We have a horizontal asymptote at y equals 0, degree 1, degree 2 in the denominator. So 1 is less than 2, so that's always y equals 0. And the last one, if you factor that, 2, that's 2x subtract 1. We go ahead and we factor the denominator, 2x plus 1 and 2x minus 1. So once again, we have the same factor. So that means that's a whole. If it's a whole, it can't be a vertical asymptote. So the vertical asymptote is at x equals a negative a half. And the horizontal asymptote is y equals 0. That's a degree 1 right there. That's the bottom is a degree 2, so 1 is less than 2, so that means your horizontal asymptote is y equals 0. Okay, so you should be able to take any of those rational functions and do that algebraically. You shouldn't need a graphing calculator to be able to find a vertical asymptote or a horizontal asymptote. Okay, so just as a refresher here, vertical asymptotes are where we find those by setting the factors of the denominator equal to 0, and then we solve it for x. Horizontal asymptotes, we're thinking about the end behavior, but we had this little formula down here that we were using where we were comparing the degree of the numerator to the degree of the denominator. And if a is less than b, it's always y equals 0. If a equals b, then it's the ratio of the leading coefficients. And so today we're going to talk about what happens when a is greater than b. So when the numerator is bigger than the denominator. So that's going to turn out to be a higher degree polynomial asymptote. So first of all, we're focusing on case 3. Um, Case 3 is they are not classified as horizontal or vertical asymptotes. They're going to have their own names. So if the numerator is bigger than the denominator, you're going to have a whole nother name to call it. It's not a horizontal asymptote. It's not a vertical asymptote. And if you have a case 3, then you definitely are not going to have a horizontal asymptote. You can't have both. It's one of the 3 cases. So case 1 and case 2 give you a horizontal asymptote. Case 3 gives you something else. So there is no horizontal asymptote if you're using case 3. So here we go. Here's a bunch of examples of case 3, and then we'll figure out what they're called, what the polynomial is and what it's called. So first of all, you're going to want to look at your degrees. So this is a degree 4, this one's a degree 3, so 4 is definitely bigger than 3. You want to find out what is the difference between the degrees. So the difference between those, 4 minus 3 is 1. Okay, if it's a degree 1, degree 1 is classified as linear. That's the type. So what they will call that, you can either call that linear, or typically you'll see the word slant because it's actually a slanted line. The vertical and the horizontal lines are our vertical and horizontal asymptotes. So now if we still have a linear one for case 3, it turns out to be a slanted line. Okay, if we look here on the second one I've got a 4 in the numerator, a 2 in the denominator. 4 is bigger than 2. 4 minus 2 equals 2. So if it's called a degree 2, then that's quadratic. So they could call it a quadratic asymptote, or they might use the word parabolic to classify its shape. So either one of those words. Okay, and then here we go. This would be a 4 and a 1 right there. So if I try to figure out the difference, 4 minus 1 is 3. So that's a degree 3. So they may call that asymptote a degree 3 or degree 3, or you will see the word cubic. It's a cubic asymptote. So we've got a couple of interchangeable words there that they will use to describe those higher degree asymptotes. And we kind of just call those all end behavior asymptotes because we're talking about the end behavior. Okay, so now we're going to have to figure out how to get that end behavior asymptote. Just not naming it, we got to figure out what is its equation actually. So when I look at this one right now, I can see that I have a degree 3 in the numerator and a degree 1 in the denominator. So I know that my end behavior, this third case asymptote, is going to be a degree 2, which is quadratic or parabolic. If I have to give it a name, I'm going to use one of those two names, quadratic or parabolic. Okay, to actually figure out what it is, the equation, you have to, this is why we learned how to do division. You have to divide the denominator into the numerator. So since this is an x minus 1, that's a perfect setup for synthetic division. So you could do long division if you wanted, but I'm going to do a synthetic chart. So I'm going to put 1 in the box, put my coefficients out in front, and then we're going to run it through the chart. Now, in this scenario, guys, you do not have to get a 0 for a remainder, and you really don't even care about the remainder. We kind of just forget about it. So the end behavior asymptote, its equation would be y equals x squared minus 2x plus 1. That's the asymptote we're after. And that's its equation. All right, let's try it again. So this time we've got 2x squared plus 2x minus 3, and I'm dividing that by x plus 1. So if I want to find out what that third type of asymptote is, we're in case 3. This is a 2, this is a 1, so I know the numerator is bigger than the denominator. So the difference between 2 minus 1 is a 1, so that means it's linear. So we're going to call this a linear or a slant asymptote. Okay, so to figure it out, we actually have to do the long division, or since this is set up with an x plus 3, we can do synthetic. We can run that through a synthetic chart. So that's going to be 2, 2, negative 3. Run it through our chart, and we end up with 9 for a remainder. But once again, guys, we don't even really care about the remainder. If we're looking for the end behavior asymptote, we just want the equation of the line. So this would be y equals 2x minus 4. And you could see if you were going to graph that, 2x minus 4, so 1, 2, 3, 4, you would be here up 2 over 1. Your asymptote, this would be your asymptote. It would be slanted. It's a slanted line. Okay, and that's what we're after. So its equation is y equals 2x subtract 4. Okay, so given the following function, find the end behavior asymptote and name it. So I'm going to first of all look to see what I'm working with. I've got a degree 5 here and a degree 2 here. So if you take a degree 5 and subtract a 2, you end up with a degree 3. So degree 3 is going to be cubic, or degree 3. So we're looking for a cubic equation. Unfortunately, because that is an x squared, you cannot do synthetic division. You're going to have to do long division. So x squared plus, I'm going to keep my placeholder, 0x plus 1, and that's going to be divided into, we've got a lot of zeros on this one, x to the fifth plus 0x to the fourth plus 0x to the third plus 0x squared plus 0x, and then on the very end, plus 1. Okay, we're going to do that long division. So this is going to be x to the third. So x to the third times x squared is x to the fifth. 0 times x to the third is just 0, so there's my placeholder. X to the third times 1 is x to the third. So after we multiply, then we change our signs, and then we add straight down. So this first column is a 0, this second column happens to be a 0, and now the third column is a negative x to the third. And then because I have 3 place values right here on the left, I need to make sure that I have 3 place values on the right. So I'm actually going to bring these next two down at the same time. 0x squared plus 0x. Okay, what times x squared gives me a negative x to the third? Well, that's going to be a negative x. So negative x to the third plus a 0, that's our placeholder, and then minus x. Okay, change our signs. Add straight down, and we end up with x plus 1. Okay, that's our remainder, x plus 1, and we don't care about the remainders when we're trying to find the end behavior asymptote. So this one's going to be a cubic. Its equation is going to turn out to be y equals x to the third subtract x. That's the asymptote we're after. That's its equation. Okay, so now we're going to have to draw the graph. We're going to put it all together, see what it looks like, make sure we show all of our asymptotes, everything that we need to on this graph. So 2x to the third minus 2x squared minus x minus 5. So when I look at that, first thing I notice, the degrees, there's a difference of 2, right? So this is going to have a parabolic asymptote. So first of all, we need to figure out what its equation is. So y equals, sorry, I don't know what it is yet. We got to do the synthetic chart. So we're going to put 2 in our box. 2, -2, -1, -5. Run it through the chart. So we end up with 2 times 2 is 4, 3, 6, 1. So I don't care about that. So I end up with y equals 2x squared plus 2x plus 3. Okay, that's the parabola we need to graph. So if we're doing this on our graphing calculator, it's a lot easier. It's a little harder to graph this by hand. We need to get its vertex. So I think I'll just do axis of symmetry. So the vertex is opposite of B over 2 times A. So that's going to turn out to be a negative 1/2. Then you're going to take and you're going to plug in a negative 1/2 into that original equation there so we can figure out what it is. Okay, so we're going to go, 2 parentheses negative 1/2 squared plus 2 parentheses negative 1/2 and then plus 3. So it's 5/2, so 2.5. Okay, so this vertex is at a negative 1/2 and up 2.5 right there. Okay, now if we were going to try to graph this parabola, it looks like it's got a vertical stretch of 2. So instead of going up 1 over 1, I'm going to go up 2. So 1, 2 over 1. And then I'm going to go up 6. 1, 2, 3, 4, 5, 6 over 1. Okay, now because this is an asymptote, guys, we're just going to kind of like we've been doing, draw that as a dashed. There's our parabola. Okay, and I also know that I have a vertical asymptote at x equals 2. So not only did we find, so there's no horizontal asymptote because it's a parabolic one, but from the denominator, we've got a vertical asymptote at x equals 2. So I'm going to come over here at 2, and I'm going to draw another dotted line. Okay, now we're kind of running out of room on our graph paper, but if you look up here, if we were to follow this out, this kind of makes an X up here at the top of the graph paper. So what you've got to be careful of, guys, is you've got to get on your calculator screen and make sure if you've got an X, so like if I've got, see, this is what I'm calling this X shape right here, this, where those two asymptotes intersected. So if there's something below the X, there's got to be something above it, or if there's something to the left, there's got to be something to the right. So when you go to your graphing calculator, you might have to look for some behavior to see what's happening. So that's about all we can do by hand right here. Um, we could find the y-intercept, I guess. So the y-intercept is 2.5. So the y-intercept is right here, just to the left of that vertex of our parabolic asymptote. Okay, now we're going to go to our graphing calculators and type in this equation, and we're going to see how what we've drawn matches the graphing calculator and see if we can actually draw in this rational function. Okay, so I've got my equation typed in. I'm going to hit graph. And so we kind of got this shape going on here. So it looks like to me that it's following along the bottom side of the parabola, and it's going through our y-intercept, and then it comes up here, and then it comes down and following this asymptote. That's what it looks like is happening. Okay, now remember I talked about this little X shape. So because I have something down here in this area right here in this area, it makes me feel like I need to go find something up here in this area on my graph. So on my graphing calculator, I'm not seeing higher up. So I'm going to go to my window and I am going to change my Y max to 25. I'm just guessing a number. I'm going to change it to 25. And then I'm going to hit graph again and see if I can, oh, can you see how we ended up with another branch of our picture? So we need to just go ahead and make a sketch here. There is something right here that follows that vertical asymptote as well as that parabolic asymptote. It's kind of curved. So you're going to have to, your screen may not give you all the information. So using the algebra and what we know, we're going to have to maybe zoom in or zoom out, I guess, on your calculator till you can see the whole picture. Okay, let's try it again. So this one, this is kind of what you're going to have to do in your homework. You're going to have to answer all these questions. So I've got x to the third plus 1 over x minus 1. Now, hopefully you remember how to graph or factor a sum of cubes. That goes to x plus 1, and then x squared minus x plus 1 over x minus 1. Okay, there are no wholes. There were no factors that are the same, so this is a none. The vertical asymptote happens to be at x equals 1. Horizontal asymptote, okay, well, to figure that out, we got to go check our degrees. This is a degree 3, this is a degree 1. So the numerator is bigger than the denominator. So in that case, there is no horizontal asymptote. We got to figure out what it is. It's going to be something parabolic. It's going to be something to the x squared. Now, lucky for us, we're dividing by x minus 1, so we can run that through a synthetic chart. So to find that, I'll come over here. I'm going to put 1 in the corner, and then I'm going to have 1, a 0x squared, a 0x, and a 1. Run it through my chart. And 1. And we end up with a remainder of 2. So 1 times 1 is 1, 0 plus 1 is 1, 1 times 1 is 1, everything. So now remember, we don't really care about the remainder when we're trying to find our end behavior asymptote. So what is the equation of it? It is y equals x squared plus x plus 1. So when we come over here and graph that, we're going to have to try to figure out how that graphs. So here's the vertical asymptote. So we need to find the vertex of that. So I guess I'll do my axis of symmetry. So x equals opposite of b over 2 times a. So it looks like, once again, my vertex is going to be at a negative a half. And now I'm going to plug negative a half in and see what my y value is. So a negative a half squared is 1/4. So we're going to have 1/4 and then minus 1/2. And then we're going to add 1. So 3/4. All right, so we're here at a negative a half and 3/4. So about right here. And then we're going to be, let's see, what is it? Oh, it's just an x squared. So we're just going to go up 1 over 1, up 3, 1, 2, 3 over 1, up 5, 1, 2, 3, 4, 5 over 1, and we're kind of in the middle there. Okay, now remember, this is an asymptote, so we're going to draw that dotted. And notice I ended up with this kind of X shape. Here's an X shape right here. See that X shape? So when I go to my graphing calculator, I'm going to really want to look to see what kind of behavior is happening around that X shape. All right. So my x-intercepts, I've got 1 at -1 from my factoring up here, x plus 1. My x-intercept is going to be at -1, 0. And then this x squared minus x plus 1, if you put that in the quadratic formula to find the other x-intercepts, they turn out to be imaginary. So we've got 1 at -1, and then what do we got for a y-intercept? Y-intercept looks like it's 0, -1. And then we'll figure out what the domain and range is in just a minute. Okay, so we're ready to go to our graphing calculators. And let's type in x to the third plus 1 over x minus 1 and see what happens. So x to the third plus 1 divided by x minus 1. Let's hit graph. Okay, so now what's happening here, if you can, let's go put in, I'm going to put in that, the parabolic asymptote that we found out. That equation right here, let me look and see what it is. It's x squared plus x plus 1. I'm going to put that in my graphing calculator in line 2 just so you can see how it's following along. So I'm going to go down here, x squared plus x plus 1. And hit graph. So now you can kind of see how the graph is following that asymptote. So we're coming right here, we're crossing at -1 and -1. So it was following along here, came down, and then it started to follow along here. And then the other part, so, oh, whoops, it didn't go down. Sorry, let me backtrack and erase that. It went on the other side of the parabola. So we're going to go right here. Let me shrink that and get rid of that last piece I drew. So it came down. Okay. My y-intercept has got to be wrong. Let's regroup here for just a minute. What did I put our y-intercept as? -1. Nope, that looks right. And our x-intercept is at -1 also. Okay, so we're going to go ahead and let's sketch that in. So this piece right here, oh, I had it right. I'm getting my colors backwards. I'm sorry. The colors that I'm drawing with are red and they're blue on my calculator, so I've got myself confused. So I had it right. It was coming along here, coming down here, and then going like this. I had it right. Talked myself out of it. And then over here on the other side, the blue piece is inside here. So it's inside here, comes along here. Sorry about that, guys. Got myself confused with the colors. Um, so there's our picture right there. Okay, domain looks like to me, if I'm going to do the domain, it looks like 1 is the only thing that doesn't count. So we could say from negative infinity to 1, and then 1 to positive infinity. Or you could say all reals except that x cannot equal 1. You could do it like that. Either way, I would take either answer. Okay, and the range, it looks like to me because I have this one continuous piece that goes almost up, you know, it's not straight up and down, but it goes up to infinity and down to infinity, that piece. That means my range is all reals. Okay, let's do it again. So once again, we're going to just start it all off. So x squared minus x minus 2 divided by x minus 3. So we're going to want to see if it will factor, and the numerator will factor to x plus 1 and x subtract 2, and the denominator is x subtract 3. So there is no whole, no like factors. The vertical asymptote is at x equals 3. So I'm going to come over here and draw a vertical asymptote at 3. And then horizontal asymptote, once again, I'm going to look right here and I see that the number in the numerator is bigger than the number in the denominator. That's a 1 right there. So that means there is no horizontal asymptote. It's going to be some kind of a slant because it's 2 minus 1, so that's a degree 1. So to figure that out, you're going to have to do the division. You're going to have to take x minus 3 and divide it into x squared minus x subtract 2. So to do that, I'll just, since my divisor is x minus 3, I'm going to run it through a synthetic chart. So 3 in my box, and then I've got 1, negative 1, and negative 2. Run it through the chart. And we don't really care about the remainder here, so we don't really care. So this is x plus 2. So the end behavior asymptote is the equation y equals x plus 2. So I'll come over here and I'll graph that. X plus 2, slope is 1. So here's the end behavior asymptote right there. So once again, I've created that X shape. So I want to make sure that I'm looking to see that I have every part. X-intercepts, there's going to be one at negative 1, 0 and 2, 0. So negative 1, 0 is right here. 2 zeros right here. Y-intercept is 2/3. And we'll do domain and range in a minute after we graph it. So here's my y-intercept right there, 2/3. Okay, so let's pull up our calculator and type in our equation. So clear that out, and I'm going to go clear the other one out. And so it was x squared minus x minus 2 divided by x minus 3. Okay, and I'm going to hit graph. And now we can see what our shape looks like. If we wanted to type in that slanted asymptote, we could. We could just go to y equals and come down here and type in x plus 2. And you can see how it's following along that asymptote. So if we go to sketch that in, we're going to follow the slanted asymptote here, comes up, and then it comes down. Now remember, I talked about that X shape. So if you've got something in the lower half here, there should be something in the upper half, and there was. We could see that on our graphing calculator. You can't always see it. Sometimes you have to go look for it. So that piece looks like this. And we're just kind of sketching. So if there's something below, there has to be something across from it in that X shape. Like vertical angles, you know, that kind of thing. That has to be in that area. Oh, whoops, forgot domain and range. Okay, so the domain, it looks like to me everything but 3 works. So the domain is, you could say all reals, x cannot equal 3, or you could say negative infinity to 3, and then 3 to positive infinity. Okay, now range is going to be a little bit harder to do because if you look, this right here, I have all this area right in here where nothing is being graphed. I'm going to have to take all of that out of the range because there's nothing there. So how are we going to do that? Well, we're going to go to our graphing calculator. And what you're interested in, guys, is the highest point here, because that's our max, and the lowest point here, that's our min. That's our range is going to go between those points. So to figure that out, let's go to our calculator and let's find a max. So that's number 4. So I want to be on the left-hand side, so I'm going to hit enter. And then I want to be on the right-hand side. So I'm going to make sure that I really get the max. So I'm going to be pretty liberal with my boundaries there. And then I'm going to come in here, enter. Okay, so our point looks like it's 1.999911. Okay, so this max point right here, oh, I wasn't too far off. That point right there is 1, 1. Okay, now let's do the other one. So let's find the min. So second calc, min, that's going to be 3. All right, my cursor is on the wrong branch, so I'm going to hit the up arrow and see, okay, if I can get it to go. Oh, actually, I don't, that only puts me to my asymptote. So I'm going to right arrow and see if it will bounce to the top there. There we go. That's what I'm after. Okay, so I'm going to figure out what the min is. So I'm going to hit enter. I'm going to go on the other side, hit enter, and then I'm going to make my guess. Enter. So that looks like it's the 0.59. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, whoops, the other way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so that's really, it should be, I got that one too low. So it should be kind of going through here like this. Okay, so that's 5.9. All right, so that means our range has to be from negative infinity, that's the lowest point, to the highest point of this branch right here, which was 1. Okay, then there was a big break, and we started at the lowest point of this branch, which was at 9, to infinity. So there's the range on that one. Okay, so you're just going to practice that over and over again in your homework. So I've got a worksheet for you to work on. You're good to go.